any two axes form a plane. Means in Cartesian we have seen we have x-axis, y-axis. So xy plane, y-axis and z-axis, yz plane, z-axis and x-axis, zx plane. In Cartesian coordinate system, similarly in cylindrical also we have planes. Okay, so that plane which phi axis represent is actually a little bit different. Okay, because that phi axis is the one which is showing representing the angle in which the point is located. Okay, so that is the phi axis. Okay, fine. Now let us start with the spherical coordinate system. So I am sharing my screen. Okay, is it visible? Is the screen visible to you?
Yes, sir.
Yes.
Yes, sir.
Not visible.
Yes,
Visible,
sir.
sir.
Oh. Now visible though. It's okay.
Yes, sir.
Okay. So now starting with spherical coordinate system. Spherical coordinate system, as I've just mentioned, that we assume that the whole universe is in the form of a sphere. So we are not strictly bounded, like any point will be with respect to in a say dimension. Okay, x-axis, y-axis, z-axis. It can be anywhere. So obviously in rectangular coordinate system also, that is the Cartesian coordinate system also, you can plot any point anywhere, no problem. But over here we can plot the same point, but the representation of the plot will be not based on the x-axis, y-axis, z-axis, as if the point is on the sphere, surface of a sphere. So in cylindrical, what we have seen in cylindrical, we consider that a point is lying on the surface of a cylinder. Okay, that means if I show you, okay, so any particular point, okay, P point P, it was suppose consider that it is lying on the surface of a cylinder. Okay, so on a surface of a cylinder. So with respect to that, we have drawn one cylinder considering the x-axis, y-axis, z-axis of the Cartesian coordinate system. That means we have seen that Cartesian coordinate system is a reference coordinate system with respect to which the cylindrical coordinate system is being represented. Here also, for the spherical coordinate system also, same thing. The rectangular, that is the Cartesian coordinate system, is the reference one, and the cylindrical coordinate and the spherical coordinate system is drawn with respect to the Cartesian coordinate system. So the spherical coordinate system is like this, that we assume that any particular point, suppose point P is there, it is lying on the surface of a sphere, three-dimensional sphere. Okay, three-dimensional. Okay. Now, if there is another point, suppose a point is over here, point Q, we will consider that it is lying on the sphere of a greater diameter, radius. Okay, something. Now, how to represent this? Because obviously it is not possible to explain this particular coordinate system on a three-dimensional coordinate system on a 2D plane, because our computer screen or your mobile screen where you are looking, okay, it is 2D. So to explain it, we have to take reference with this coordinate system. Otherwise, we will not be able to understand. Okay. So see, this is the coordinate system. Cartesian coordinate system, XY plane. Okay, XYZ axis. As I've told you, that spherical coordinate system is also drawn taking the rectangular coordinate system or Cartesian coordinate system as reference. Okay. So any point P. Okay. So first of all, if a point is on the surface of a sphere, suppose you take a ball, okay, tennis ball. You look at a point on the sphere. So what it represent? It means that it is on the surface of a sphere. So it can move like this. Okay. Similarly, so taking that surface arc, you draw a sphere. Okay. You draw a sphere. Now that sphere obviously it should be uniform like this. Once again, it should be uniform like this almost. It is having some radius. It is having some radius the origin. So it should be such a way that the center of the sphere should be at the origin. However, if the point is over here, suppose your point is over here, so you draw a circle taking this center as the origin in this way. Okay, whatever. Okay. So now that means this is now this is okay, we can remove this. This is the radius. This is the radius r. Now this point P could have been here also, P dash. Point P could have been here also, P double dash. That means radius it will be equal. This is also R. This is also R. Okay. Because radius will be same. We know the radius is always same. But the point P could have been some in other place also. How to locate this? Where it is? For that we measure the angle with respect to Z axis. That is why we measure an angle with respect to Z axis. This angle. If the point P was over here, then this angle. If the point P was like in P dash, then this will be a greater angle. If it is P double dash, for more greater angle. Okay, so angle will increase. Okay, in that way. Since our point P is over here, so point P, not P dash and P double dash, so we will take this angle. This angle is called theta. How to measure this? We will measure this angle between the radius and the axis. Okay. This is so what we have come to know that there are three coordinates. First one is radius. Second is theta. Okay. Second is theta angle. Second is theta angle. There is another third. The third coordinate is common to cylindrical coordinate system. What is that? It is not the radius because radius we already have. It is not the height. It is the phi. Okay, in cylindrical coordinate system, we had three coordinates rho, phi, z. But phi was the second coordinate. Over here, phi is the third coordinate. Phi is same because phi is represented in this way. Suppose this point is over here. So visualize because it is once again not possible to explain in the two-dimensional screen. Visualize that the ball which you are holding, you are marking a point on the surface. Okay. You move the surface over here, okay, suppose over here, point over here, somewhere over here, okay, or somewhere over here. Visualize in that way. Suppose I remove these things. I remove this portion. Suppose the particular point is over here. This is a sphere, so it is a sphere like this. Just imagine that this particular point P is also having a radius equals to r, similar to this radius. This is also r. If it is located over here, then if you draw the mirror image on the xy plane, so what angle it is making? That is phi. So same thing. So radius will be there, angle will be there theta, and another angle phi. So two angles are there. In spherical coordinate system, we have two axes are there which are actually measuring the angle. Okay, and one is the distance. Okay. So going back to the actual PPT. So see over here, we have the point P. So R is the radius, theta is the angle with respect to the z-axis, phi is the angle with respect to the plane. Okay, with respect to the x-axis actually. Two angles are there. Now two angles. Now the three axes are there. Now three axes will have three. You can say unit vectors. So the radius R is actually pointing towards the located. It is actually in the direction of the point. So the unit vector will also be, the axis will be along the direction. Okay, so the unit vector will be along the direction. If the point was over here, suppose, if the point was over here, okay, over here, the radius would have been same r, so the axis will be like this, same thing. Okay, now the second axis is the radius, the angle theta. Second coordinate is angle theta. So the angle theta, that axis will be tangential to the surface. Tangential to the surface. That means it is making an angle, okay, like this. Suppose this point is over here, so the angle theta would have been this. So it is moving in a clockwise direction, so that unit vector would have been tangential. Okay, and this should be 90 degree. Here also you can see this angle is 90 degree. These two are 90 degree. Okay, these two are 90 degree. Sorry, this one this is 90 degree. Means the radius, unit vector of the radius and unit vector of the theta are perpendicular to each other, and you know that the unit vector of the uh, phi will be tangential to the surface, okay, because it is in this angle. So whatever angle you have, it is tangential. It is similar to the cylindrical coordinate system. Okay. Once again, all these three are perpendicular to each other, so they are orthogonal. Okay. Now coming to the range. Okay, so r is the radius. Obviously, it will be from 0 to infinity. Now, this particular phi, you know, 0 to 2 pi. Theta is from 0 to pi. Okay, theta is considered to be 0 to pi. Okay, because the other way around also it will be same, 0 to pi. Because suppose you have a point, you have to imagine in this way. Suppose you have a point. Suppose this is minus z. Okay, this is minus y, and minus x is behind. Suppose you have a point over here. Okay, point Q. So if you have a point Q, so first of all, the radius will be r. Suppose radius is not changing, it is r. Okay. Angle will be minus theta. Minus theta means 2 pi minus theta. Okay, so it is 2 pi minus theta, this angle, minus theta. And this phi will be, it is from 0 to, sorry, theta is pi, and this phi is 0 to 2 pi. Okay, so this is theta. This won't be minus theta, this is plus theta. Okay, plus theta, because the range of theta is 0 to pi. Here also it is 0 to pi. Okay, how to understand that if it is on the left hand side, because the phi angle will change. If this is phi, then if the point is over, it will be minus phi. So if it is minus phi, then only you can understand that suppose you have a point, suppose 5, 30 degree and 45 degree. You have another point which is 5, 30 degree minus 45 degree. So obviously if it is minus 45 degree, you can understand this point is on the left hand side, on the minus y-axis. Okay, so you can understand from there. That is why the theta angle is not represented. Okay, someone is joined again. Okay, so theta point is represented from 0 to pi, because it is not required, because if you are able to since phi is ranging from 0 to 2 pi, so if you are able to make out that if it is an angle is means minus phi, so that means minus at 45 degree, that means it is 360 minus 45, so it is 315 degree. So from there we can understand that it is in the negative y-axis, okay, in that direction. That is why we don't have to, once again implement that, once again represent theta in minus also. That is not required. Okay, for that it is represented this way. Now in vector, if you want to represent a vector in a spherical coordinate system, the process is same. You will have three coordinates and three associated with the three, you can say, unit vectors. Okay, magnitude will be represented by the square root of the square of summation of the square of individual coordinates. Okay, this is also known to you, that dot product, okay, and cross product, you will get the third coordinate if you do the find the cross product of the two other coordinates. And now coming to the differential length, differential area and differential volume. Okay. So differential length, once again, see, imagine there is one point. Okay, now you will be able to understand, because this becomes self-explanatory, because since you have already gone through the two coordinate systems, Cartesian and this cylindrical, so you can make out of your own. Okay. I'm just showing you different points, okay, so that you can grasp it very quickly. First two points are there, same way, P and Q. So now P is having a radius of say R. Okay, this is the radius, uh, because you have to observe that these are in the spherical coordinate system, so you have to act accordingly. You have to plot them accordingly. Okay, considering the spherical coordinate system. This is R, this is theta, and this is the mirror image, suppose. Okay, or you can say you are taking the curve, so this lies over here, so this angle is no problem. Now you have to reach Q following the three different coordinates. So you have to move along this line, okay. Or rather, I would say you have to first follow this path, because first coordinate is R, radius. So the point Q is having a radius greater than point P. You have to extend it over here. This is additional, you can say, radius. Then additional angle theta. Angle theta you have to increase. Then you have to increase angle phi. Then only you can reach point Q. From there you can again draw some cutouts. Okay, one segment. You can draw the segment. Now the additional radius, suppose dr. No problem. This additional radius is dr. It is shown over here. Now this segment, that is theta, okay, increase in theta, is represented as r sine theta d phi. Okay, wait, let me see. Sorry, this is r d theta. Okay, sorry, this is r d theta. This segment is r d theta. This one increase. Why? Because we know that previously it was theta. Now the angle is theta plus d theta. Okay, theta plus d theta. So what is this increment? Because total angle, if I say, if I represent the total angle, suppose this line is over here, this one, suppose this is the line. So this total angle, this one is theta plus d theta. Okay. So what is this additional angle? It is d theta. So d theta means, so what will be this curve then? So obviously using the arc formula, okay. So it is radius into the angle, is r d theta. Imagining that dr is very small, and now this curve is represented as r sine theta d phi. Why? Because this angle is phi, then the new point which is there, point Q, okay, suppose this point, it is lying over here. So this angle is dq, okay. Now if this is dq, then what will be the arc value? It won't be equals to dq, it will be r dq, but r dq you cannot write because in cylindrical coordinate system, if you can remember, you have written r dq because cylindrical coordinate system was different. Yes, phi was not dq d phi, sorry, r d phi. You cannot write r d phi because in cylindrical coordinate system you have written r d phi. Why? Because first of all, cylindrical coordinate system, in the cylindrical coordinate system, the phi coordinate what is in the middle. That means the second coordinate. But in spherical coordinate system, it is the third coordinate. Number two, in cylindrical coordinate system, you had radius and z-axis. So only one angle was there. But in spherical coordinate system, you have two angles. Other than phi, you have also theta. So this is radius r, okay, and this angle is phi, okay. So this will be r sine theta d phi. Why? Because you have to imagine this way. If this is, suppose you focus on this marker which I am showing you. This point P, the origin. This line is radius. Okay, this is the radius. Now, if you visualize in this way, this is radius. Now this is z-axis because z-axis is there. Suppose it will always be there, and you draw an extended line over here. Okay. Now it will create a 90-degree angle because this line, this one is a right angle triangle where this is the angle theta. Now this is base, this is perpendicular, this is hypotenuse. Okay. Obviously this line, okay, this line, okay, which is being represented blue line, this blue line will be r sine theta because if this is r, okay, this is r, this will be r sine theta. Oh, sorry, one second. There's a mistake. This is not 90 degree actually. This is 90 degree. Yes, this will be perpendicular because see this is radius and you have to draw a perpendicular line with respect to the z-axis. So this is perpendicular. So this is actually the hypotenuse. This is base. So, okay. So this is r. So the hypotenuse is r. This one. So this will be r sine theta and this one will be r cos theta. Okay. That means this is the hypotenuse, then this line will be r sine theta and this base will be r cos theta. And this is r sine theta. Okay. So this arc, okay, this arc is represented from here. Okay, it is represented from here. Okay. That is why it is considered because this arc is being measured. You can see this arc is measured because this one is the mirror image of arc over here, okay, and over here this is also one arc. These are two arcs, okay. Let us consider this bottom one, not the upper one. I am removing the upper one. I am only concentrating on the bottom one, this one. So this is dq. This arc is there. This arc and this arc are equal. Okay. Now this arc is formed because of this line. Now what is the length of this line? It is r sine theta because this is r and this is theta. So this line is r sine theta. This line is r sine theta. Now this is the length. Now arc following that length will be r sine theta d phi. Got it? Were you able to understand this part? Shall I repeat? One second. Am I audible?
Yes, sir.
Okay, so did you understand this part? Okay, let me explain once again. This dr concept is okay, I think. Okay, dr you have understood, and this r d theta is also, I think you have understood this part. This is d theta, so radius into d theta. Okay, no problem. Now, one more arc is there, which is the this arc, which is the d phi arc. Okay, d phi angle. So arc with respect to d phi. So this d phi is over here also. If we are able to measure this arc, then we can represent the same thing over here also. Same thing. Okay. Now, to understand this, first you have to see we cannot measure with respect to this. Okay, we have to measure with respect to this. Okay, because it is formed from here as if. Okay. So for that we will consider a right angle triangle. We have a theta over here. So what we will do, we will draw a perpendicular line such a way that this triangle is formed perpendicular. Now this is r. This length is r. This red line is r. Okay, this is hypotenuse. This is base. This one will be r cos theta, and this one will be r sin theta. Now it is forming the arc. That is why it is r sin theta d phi. Okay, so it is r sin theta d phi. Now once again the transformation. We can carry on with the transformation. Now transformation between Cartesian and spherical. Why? Because everything is represented with respect to Cartesian, because the theta angle we have seen it is with respect to z axis and phi angle is with respect to x axis. So once again with respect to Cartesian coordinate system. But we can also represent with respect to cylindrical also. So that means same point P can be represented in Cartesian coordinate system or cylindrical coordinate system or spherical coordinate system. This is spherical, this is cylindrical. Okay. Okay. So now this point P. Now you know the relationship between the Cartesian coordinate system and the cylindrical coordinate system. We have seen, because it is also represented over here, because this relationship is between all the three coordinate systems together. Okay. So here it is once more repeated, the relationship between Cartesian and cylindrical, which we have already discussed in the previous lecture. Okay. So this is, so with respect to that, if you see, this was the radius r. Okay. Rho is different. See, rho cylindrical rho is radius is different. It is with respect to z axis, perpendicular to z axis. But spherical radius is from the origin. Okay. This is why it is making an angle theta. Suppose there is a point P and you are plotting the point P with respect to the spherical coordinate system. So it will have radius, okay, radius like this r, okay, radius r. Okay. Now angle is theta, and if you draw it over here, then you get a plane. You get a plane that is phi. Obviously, you can see this line is equals to this line. It is the value of rho, which is coming in the, which is there in the cylindrical coordinate system. So we are concentrating on the spherical and Cartesian. Okay, first of all, Cartesian and spherical. So this is r radius. You're drawing a mirror image over here. Okay. So now you can see you have to consider this one once again. This is the, okay. So if you are only concentrating on Cartesian and spherical, so I can remove this part. Okay, I can remove this part. So concentrate on this particular right angle triangle. Right angle triangle. Suppose this is the radius of the particular point, which is in the spherical coordinate system. This one, R radius. Okay, we draw a perpendicular line over here. Okay. We get a right angle triangle. Why we are drawing perpendicular line? Because just for our simplicity, we are drawing the perpendicular line. But once we draw the perpendicular line, we are indirectly getting the value of rho, which is the first coordinate of the cylindrical coordinate system. Okay, but we will ignore that. We will only draw a right angle triangle. We will see that if this length is r and this is the angle, okay, this is the perpendicular angle. That means this is the perpendicular line. So this is hypotenuse, this is base. So if this is r, so this length will be r cos theta, and this is r sin theta. Okay. So r cos theta is nothing but the height z. That means z is equals to r cos theta. Okay. Z is equals to r cos theta. Okay. Now, if this is r sin theta, this one, then we have to plot it. If you take the mirror image, okay, forget about rho. Okay, don't have to consider about rho. Forget. Just you don't have to concentrate on this. Concentrate that this is the mirror image. This is r sin theta. So this line is also r sin theta. Okay, r sin theta. Now this is r sin theta. Now you once again you take a right angle triangle like this. You make a right angle triangle like this. Okay, right angle triangle as if this angle is phi. Okay, yes, this angle is phi. This is total is 90 degree. Suppose 1 second. Perpendicular. Right. Uh, Let me remove this part. Okay, so this is r sin theta. Okay, so this portion. Okay, so once again, if you take a right angle triangle with respect to this one. Okay, so yes, this is right angle. This is the 90 degree. So this is 90 degree. Suppose this is 90 degree. You take a right angle triangle. Okay, so this is perpendicular line. So now this line is r sin theta. This one. So this is hypotenuse. This will be base. What will be this line? Okay, remove this part. Okay, don't have to concentrate on this. So what will be this blue line? This is r sin theta. This is phi. So this line will be r sin theta sin phi. Why? Because r sin theta is a whole unit variable. Now this is hypotenuse. So because we know that if hypotenuse is h, so we write perpendicular equals to h sin phi, isn't it? And base we write h cos phi. So h is r sin theta. So r sin theta sin phi, and this will be r sin theta cos phi. So y axis is r sin theta sin phi, x axis is r sin theta cos phi. Okay, this is the transformation from spherical to Cartesian. Now from Cartesian to spherical, quite easy, because the radius, because if you have x, y, z coordinates, then the radius will be square root of summation of the square of all the three coordinates of the Cartesian coordinate system. Okay. Theta, what about theta? Then you have to concentrate on this particular right angle triangle once again. Theta matlab, okay, this is the theta angle. So theta we know how, in a right angle triangle, how to measure theta. Perpendicular by base. Okay. What is perpendicular? Perpendicular is this line. Okay, this line. So this theta will be perpendicular by base. So z, okay, sorry, this is perpendicular, this is base. It will be this one. Okay, so this line, so r sine theta by r cos theta. So tan. What is this line actually? This line, what is this line? You have to bring these cylindrical over here also, but I'm not, I'm trying to avoid that. Okay, so this line is actually equals to this line. What is that? R sine theta. Okay, r sine theta. But in terms of x and y, what we can write? In terms of x and y, because this line, if you see, this is x. If you concentrate on this blue right angle triangle, this is x, this is y. Okay, once again, because y is equals to this, y is equals to this, but it is actually y. Okay, measurement is y. तो ये जो है r sin थीटा, ठीक है, ये वाला लेंथ है, ये लेंथ का वैल्यू क्या होगा? इट विल बी इक्वल्स टू पावर ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर. Okay, this x square plus y square. So x root over of x square plus y square equals to r sin theta. Anyway, this is equals to root over of x square plus y square. ठीक है, अब डिवाइड करते हैं, मान लो डिवाइड करते हैं तो क्या होगा? रूट ओवर ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर डिवाइडेड बाई जेड, क्या होगा फिर? इसका मतलब क्या है? r sin थीटा और दिस इज r cos थीटा. It is nothing but tan theta. So that means theta is equal to tan inverse of root over x square plus y square by z. And phi will be this right angle triangle tan inverse of y by x. Okay, same thing. Now if I remove this, and then if you visualize the cylindrical first, because कार्टेशियन और स्फेरिकल को जानने से पहले कार्टेशियन और सिलिंड्रिकल का अगर तुम याद रखोगे तो इजीली कर पाओगे. कैसे? बिकॉज सी दिस पॉइंट P, दिस इज रेडियस, दिस इज द रेडियस ऑफ द सिलिंडर, दिस R is the radius of the sphere. So rho we already, it is known to us that it is equals to R sin, it is equals to actually this one. Okay, this right angle triangle we know, but this right angle triangle is new to us. Okay, so from there we can derive. Okay, you can do it of your own. Okay, then it will be easier for you. If you do it of your own, that will be easier for you to understand. Okay, I will come to the vector later on. Okay, first of all I am just showing the scalar part. This table will help you to understand the actual transformation between all the three coordinates: Cartesian, cylindrical and spherical. Okay, so Cartesian to Cartesian we all know same thing. Cartesian to, so that means to, and this is from. So from cylindrical to Cartesian, that means from cylindrical means cylindrical coordinates are known to us. You have to determine the Cartesian one. So whatever is in the left hand side, you are actually determining, and whatever is on the right hand side, it is known to us. So from here we are calculating the Cartesian. From spherical to Cartesian, then coming to Cartesian to cylindrical. So Cartesian to cylindrical. And this term arc tan means it is tan inverse. So don't get confused, it is tan inverse. Okay. Spherical same, because these diagonal are actually equal to each other. So that is why it is represented in this way. And spherical to cylindrical we can calculate. This is also very interesting. Why? Because see, R. Okay, this is R. And this one was 3. So rho is equals to r sin phi, where rho is the radius of the cylinder, r is the radius of the sphere. So rho is equals to r sin phi. This is one relationship. Okay, from there we have represented like this. Okay, rho is equals to r sin phi somewhere over here. Spherical to cylindrical to spherical, rho is equals to r sin phi, this one. Now cylindrical to spherical, that is also quite interesting. Cylindrical to spherical, how? Because how can you calculate r if you have rho and z? Quite easy. See, this is r, this is rho, this is z. So rho is this, z is this. So obviously root over of rho square plus z square will give you r, isn't it? Okay, so this is in this way you can calculate. It's quite interesting. It depends on the geometry. Okay, so basically trigonometry part, right angle, triangle, all these things. It is quite easy. Okay, so this particular table will help you to calculate any or transform any particular coordinate scalar point or any coordinate system to another coordinate system. Okay, so is it okay for you? So did you understand the transformation part?
Yes, sir.
Okay, so fine. Then we will in the next class I will concentrate on the vector transformation because the vector transformation is left out. Okay, because I wanted to first go through the scalar transformation, then we can come to the vector transformation. Okay, so it is already time. So whatever you go through this, and you can check out the YouTube channel. Okay, which I've just mentioned. In that YouTube channel, you can see these lectures are there. Okay, so you can get some idea once again from those. If you have missed out something due to network issue or you have joined late, whatever, you can again revisit those lectures. Okay, over there. And whatever problem you have, you can ask me in the next class. We will discuss over there. Okay. So thank you then. Today you can leave now.
Thank you, sir.